My name is Faisal Maman, and I'm really happy to be here talking to you guys. I've seen a handful of the field day videos on YouTube as I'm searching for help on different topics. Very honored to be here talking in front of you guys. The topic for the next roughly 10 minutes is going to be about Service Mesh. I'm going to go a little bit, just how Service Meshes work, and then we'll talk a little bit about what NGINX is doing on the Service Mesh front. That little girl there is my daughter, 3.5 years old. Loves messing with the old man. So if I tell her, hey, Salma, we're going to take a picture, why don't you smile? Of course, she's going to stick out her tongue and make a funny face. Yesterday, I was telling her to put her shoes away where they belong. So she takes her shoes and throws them in the middle of the kitchen.
Perspective.
Yeah, that's right. I can't wait to see what she has.
It only gets worse from there.
For me. That's what I was just going to say. I can't wait to see what she has in store for me as a teenager.
Wait.
So this is just the beginning. So I'm a software engineer here at F5 in the NGINX BU. I started off as a developer at Cisco Systems, which I'm sure a number of you guys are familiar with. Classic networking company. I was a developer there for about 8 years, and I got kind of tired of being an engineer. I wanted to see the world, talk to people, interface with customers, so I moved out to the marketing world as a TME, as product marketing manager. Actually reported to Rob for some amount of time, and then I got tired of that being out in the world stuff and wanted to get back to the lab, write code. So I recently transitioned back to being a developer. So this is a good quote. My friend Floyd constantly brings this up. So it's always stuck in my mind. I think it's a very interesting quote, very true. If you look through software systems, there's always a ton of indirection to actually get to what the thing is that you're doing underneath it. As I was researching this quote online yesterday, it may not actually be David Wheeler that made this comment. It might be someone else named Brett Lamson. And sometimes there's a little ... except for the problem of too many levels of indirection, or the other one is sometimes that'll just create another problem. But nonetheless, a great quote. So Service Mesh, just another level of indirection. Yes and no. So what Service Mesh does at a very, very high level, what we're accomplishing is putting these sidecar proxies alongside each application service. So you have your microservices-based application, and you have whatever services that compose that application. And instead of allowing those services to talk to one another, the east-west traffic, to get information, to get whatever work needs to be done, we attach a sidecar proxy to each service. And so now instead of talking to each other directly, the communication happens through the sidecar proxy. There's a number of different implementations of Service Mesh. The one we're all mostly familiar with is Istio, because they were first to market and basically coined the term Service Mesh. But there's Console Connect, Linkerd, Kong recently announced their own version of Service Mesh, and of course, we at NGINX are working hard on our Service Mesh solution. So why have a Service Mesh? Why have this additional level of indirection? Why this additional level of complexity? So there's 4 main benefits that you get from Service Mesh. One is on the security side. Instead of having each service manage TLS encryption and the certificates itself, if we have a sidecar proxy, we can have the sidecar proxies handle all the certificates, SSL termination, and ensure that all the service-to-service communication is encrypted. With sidecar proxies, we can also do traffic management. So we can do blue-green deployments. We can do traffic shaping, a lot of the stuff that Michael talked about in his presentation and in his demo, we can do in Service Mesh environments by having those sidecar proxies in the middle. There's always the visibility problem. Networking is always constantly, I guess classically, not constantly, but classically been a visibility issue, what's going on in the network. And so with sidecar proxies, we can collect metrics, feed those back up to a central control plane. There's also debugging as well. We can do open tracing, so we can trace transactions from end to end and see what goes on in between where it goes, and use that as a debugging tool. So there's a lot of good benefits to Service Mesh. So how do we accomplish this Service Mesh? So as I mentioned earlier, the Service Meshes are a transparent proxy. So the applications don't actually need to be changed. Your application is deployed just as it is, and the sidecar proxy transparently intercepts each traffic. So how do we do that? So the first thing that we do is we inject the sidecar into the pod. So the pod within Kubernetes is the smallest form factor that is available to you. And so within your pod, which typically, if you're not using a service mesh, would just be your single application, you're going to go ahead and inject that sidecar. And there's two different ways to do it. You can manually inject it, so that means you have your application YAML file, you run some CLI command on it, and it'll spit out a new YAML file with the original application and the new sidecar attached to it. Or you can do an auto injection where there's some sort of watcher. The control plane of your service mesh is going to be watching for changes. So if a new application is deployed, it's going to automatically detect that and then inject the sidecar for you. So you can do it both ways. Then what happens? The sidecar is not just one container. It can be multiple containers. And typically, it's two containers. So there's an init container. And what that does is it sets up IP tables rules. So that's how we intercept traffic within a service mesh environment, is using IP tables rules. So we just have, the very simplest level, you can have a simple IP tables rule that just says, hey, all traffic inbound and outbound, let's go ahead and redirect that up to this different service on this particular port. Or you can, of course, do it piecemeal and only intercept certain amounts of traffic. And so what the init container does is sets up those IP tables rules. So I have an init container, and that is because you need typically special permissions to set up IP tables rules. Specifically, it's the, I forget what the actual permission is, but there is some special permission. I think it's netadmin, actually. But whatever it is, you need those special permissions to set up IP tables rules, and you don't necessarily want your sidecar proxy that's running, for the lifetime of the application to have those special permissions, because then it just opens up another point of vulnerability and attack. So you want to limit the permissions. So the init container just runs, does its thing, and then disappears. But then your actual sidecar starts, and that's what takes the intercepted traffic from your IP tables rules, does the processing that's necessary, and then retrieves the original IP address and port. And that's typically done by a syscall. That's how we do it in our service mesh implementation. So whenever you do an IP tables redirect rule, the operating system saves the original destination IP and port for you, and then you do a syscall to retrieve that. So we take in the intercepted traffic, we do our processing, we get the original IP address and port, and then we send it back onto its original destination. That's all the data plane stuff. And then, of course, at the top of the data plane layer, there's a control plane, which is monitoring Kubernetes, basically, for changes in your application topology. So if a new service is deployed, the control plane is going to watch that and then push down the new route to the sidecar proxies. So very, very high level how service meshes work. So why is F5 building a service mesh, and what are we doing on the service mesh front? So why are we doing that? In that it kind of completes our vision of having a central control plane where you can manage your load balancing, API management, and now your service mesh. Some things that we're doing that we think are a little differentiated on our service mesh side is that we are focusing on hybrid applications. So most applications within enterprise companies today are not just natively built with Kubernetes. There's stuff that's built 20 years ago, 30 years ago. They might be running on physical hardware. They might be running on virtual machines. And so what we're doing is we're trying to build our service mesh such that you can use it with your Kubernetes applications, and you can also use it with your legacy applications that run outside of Kubernetes. Okay. And so this is our architecture for our service mesh. So one thing that we're doing on the service mesh side is that we are using a collection of open source components. So we're not trying to build the whole thing ourselves from scratch. There's a lot of good stuff out there within the open source community. So we're bringing that in and using that within our service mesh. So starting at the bottom level, we're going to work across multiple different infrastructure options. So there's Kubernetes, of course, which is the de facto standard for service mesh for microservice-based applications. But we're also going to work with VMware, AWS, and even bare metal applications, right? So we're going to bring those applications into our service mesh. Then there's the data plane layer, and that's where the sidecar proxies run. On top of that is the control plane. And so that's where we're going to monitor for changes within Kubernetes. So if there's a new Kubernetes application that comes up, we're going to catch that, make the necessary changes to the data plane layer, push those down. But we can also monitor registries within VMware and other configuration databases that you might have to create that central control plane layer that pushes policy down to the sidecar proxies. And at the top level, we're going to have our management plane. That's our NGINX controller product. And that's where you're going to deploy the service mesh. And that's where we're going to feed back in metrics as well. So that's the controller. And then we also have a number of open source components that we're using. So we're using Spire. If you're not familiar with Spire, that is a open source certificate authority. So we're using Spire to do our MTLS. So whenever a new service comes up within your service mesh environment, Spire is going to generate a certificate for it, and then it's going to get pushed down to the service. And anytime that service wants to communicate with another service as either a server or a client, that certificate will be used. We're using Grafana for metrics and visualization, and open tracing, as I mentioned earlier, for tracing, transaction tracing throughout the service mesh application. All right, and that's my presentation. Did you guys have any questions?
Yeah, if you have teams that are going through and deciding that they wanted to utilize a different service mesh, they're using, HashiCorp's console, and they're like, okay, that's great. We want to be able to integrate that in to what you guys are providing. What sort of interfaces are you folks providing? Are you doing SMI, or are you doing any of the open standards around, service mesh, the open standard service mesh interface that Microsoft is hosting, like with a bunch of others? What activities are happening there?
Sure, great question. So the question was just on federation, different service meshes. Are we doing anything to integrate them? What are we doing? Open standards are we using? So there's a couple of different things. We are actually implementing SMI, so that will help. If both service meshes use SMI, we'll have that common interface. We're also using Spire and the SPIFFE standard, which is a standard for identity. Istio uses that, and I believe Consul does. I'm not entirely sure. But any other service mesh that uses that identity system, we should be able to federate with them to have a common identity system as well. And that once we have that identity system, then we can have communication between different meshes.